Hi dear children, welcome to today's class. Today we are going to discuss exercise 5.1, first exercise of the chapter, continuity and differentiability. Okay, before that, if you want to say a function is continued at x is equal to c, you need to prove limit x tends to c f of x is equal to f of c. And the left hand limit is, that is, limit x tends to c minus f of x. Or we have one more definition for this left hand limit, that is limit h tends to 0 f of c minus h. Okay, c, if you are checking the left hand limit at c, then that is limit h tends to 0 f of c minus h. And the right hand limit is limit x tends to c plus f of x. Or the right hand limit at c, that is limit h tends to 0 f of c plus h. We will use these two definitions in our problems. The first question, prove that the function f of x is equal to 5x minus 3 is continuous at x is equal to 0, at x is equal to minus 3 and at x is equal to 5. We need to prove f of x is equal to 5x minus 3 is continuous at x is equal to 0, x is equal to minus 3 and x is equal to 5. Okay. So, the first case, the value of c is 0. We need to check the continuity at 0. So, the value of c is 0. We need to check whether limit x tends to c, f of x is equal to f of c. That we need to check. So, first case, x is equal to 0. The value of c is 0. So, f of c is equal to f of 0 is equal to, just put x is equal to 0 in this. We will get 5 into 0 minus 3 is equal to minus 3. Okay. And limit x tends to 0, f of x is equal to, limit x tends to 0, f of x is equal to, limit x tends to 0, 5x minus 3. The value of f of x is 5x minus 3. Now just put x is equal to 0 and thus we will get 5 into 0 minus 3 is equal to minus 3. Okay, that is limit x tends to 0, f of x is equal to f of 0. Limit x tends to 0, f of x is equal to f of 0. Therefore, the function is continuous at x is equal to 0. Now we will check the continuity at x is equal to minus 3. X is equal to minus 3. Then f of minus 3 is equal to 5 into minus 3 minus 3. Okay, just put x is equal to minus 3. Then we will get 5 into minus 3 in minus 3. What is that 5 into minus 3? That is minus 15. Minus 15 minus 3. Minus 15 minus 3, that is minus 18. Now limit x tends to c, f of x is equal to, limit x tends to, here the value of c is minus 3, f of x is 5x minus 3, that is equal to 5 into, just put x is equal to minus 3, 5 into minus 3 minus 3, that's also we will get it as minus 18. Here also thus limit x tends to minus 3, f of x, limit x tends to minus 3, f of x is equal to f of minus 3. Therefore, the function is continuous at x is equal to minus 3. X is equal to 5. F of 5 is equal to 5 into 5 minus 3. That is 5 into 5 we will cut it as 25. 25 minus 3, that is 22. And limit x tends to 5, f of x is equal to, limit x tends to 5, 5x minus 3, that is equal to 5 into 5 minus 3 is equal to 22. So in this case also we will get limit x tends to 5, x tends to 5, f of x is equal to f of 5. That is, the function is continuous at x is equal to 5. Okay, now the second question, examine the continuity of the function f of x is equal to, examine the continuity of the function f of x is equal to, second one, f of x is equal to 2x square minus 1 at x is equal to 3. 2x square minus 1 at x is equal to 3. Okay. So f of the value of c here, it is 3. Then f of c is equal to f of 3 is equal to 2 into 3 square minus 1. That is 2 into 9 minus 1. 2 into 9 is 18. 18 minus 1 is 17. Now we need to check the continuity at 3. So limit x tends to 3, f of x is equal to limit x tends to 3. The value of f of x is 2x square minus 1. That is equal to 2 into 3 square minus 1. That is 17. Therefore, limit x tends to 3, f of x is equal to f of 3. Limit x tends to 3, f of x is equal to f of 3. Therefore, the function is continuous at x is equal to 3. Third question, examine the following function for continuity. Examine the following functions for continuity. First sub question, f of x is equal to x minus 5. F of x is equal to x minus 5. Okay. So before going to this question, we have some continuous functions. That is, polynomial function is always continuous. Polynomial functions, that is always continuous. Sin x, cos x, all these functions are continuous. And if we know that by using the algebra of continuity, the sum of continuous function is continuous. The subtraction f minus g is continuous, fg is continuous, f by g is continuous. Okay, and if p of x is continuous and q of x is also continuous, then p of x divided by q of x. Okay, p of x divided by q of x, that is also continuous. And this p of x divided by q of x, that is called a rational function. Rational function. Okay, if p and q are continuous, then p of x divided by q of x, that is the rational function, is continuous. So every polynomial function is always continuous, and rational function is continuous. Sin x is continuous, cos x is continuous. Okay, so these are some continuous functions. Now, in third question, we need to examine the continuity. We need to examine the continuity. So that is, first one, third question, first one, f of x is equal to x minus 5. F of x is equal to x minus 5. We know that this x minus 5 is a polynomial. Okay, this x minus 5 is a polynomial in x, and the polynomial functions is continuous always. Therefore, this is continuous. Okay, since f of x is a polynomial. Since f of x is a polynomial. Now, the second one, f of x is equal to 1 divided by x minus 5. F of x is equal to 1 divided by x minus 5. The numerator is 1 and the denominator is x minus 5. Numerator is 1 and the denominator is x minus 5. And this numerator, that is actually a constant polynomial. Numerator, that is actually a constant polynomial. Okay, numerator, that is constant polynomial. There is no x. Okay, there is no term which contains x, so that is a constant polynomial. And the denominator, that's also a that is a polynomial. Denominator, that is a polynomial. Okay, numerator, that is a constant polynomial. A constant function is always continuous. Okay, constant function is always continuous, and the denominator is a polynomial, that is always continuous. That means the numerator and denominator are continuous. Okay, numerator and denominator are continuous. Therefore, this function is continuous because this is in the form p of x divided by q of x, rational function. P and q are continuous. P and q are continuous. Therefore, f of x is continuous provided x not equal to 5. X not equal to 5. So, f of x is equal to 1 divided by x minus 5 is a quotient function or rational function of two polynomial. So, f of x is continuous at all values of x provided x not equal to 0. X not equal to 5. If x is equal to 5, this is become not defined. Okay, so this function is continuous provided x not equal to 5. Now the third one is f of x is equal to x square minus 25 divided by x plus 5. X square minus 25 divided by x plus 5. So I'm going to make one adjustment here. Numerator, that is in the form a square minus b square. A square minus b square. So we can split this numerator as a plus b, so x plus 5 into a minus b, x minus 5 divided by x plus 5. So this x plus 5 get cancelled and we will have x minus 5. Okay, numerator in the form a square minus b square, and we know that a square minus b square is a plus b into a minus b. Okay, so we will get finally our f of x is x minus 5. This is a polynomial, x minus 5 is a polynomial. So f of x is continuous at all values of x. Now the fourth one, f of x is equal to f of x is equal to mod x minus 5. F of x is equal to mod x minus 5. Okay, and we know that this modulus function mod x, we can write it as x if x greater than or equal to 0, minus x if x less than 0. Okay, so mod x, we can, the splitting corresponding to mod x is x if x greater than or equal to 0, minus x if x less than 0. So I am going to write this f of x as f of x is equal to mod x minus 5. F of x is equal to mod x minus 5, and this is equal to, similarly instead of this x we have x minus 5. So x minus 5 if, just replace your x by x minus 5. X minus 5 greater than or equal to 0, and minus of x minus 5 if x minus 5 less than 0. X minus 5 less than 0. Or this we can rewrite x minus 5 if, just take this minus 5 into the side, then that is become plus 5. So x greater than or equal to 5, and minus of x minus 5 if x less than 5. If x less than 5. Okay, so actually our f of x is x minus 5 if x greater than or equal to 5, minus of x minus 5 if x less than 5. Now we will check the continuity. Okay, now just listen. If you took this part, the first part, if x greater than or equal to 5, we have x minus 5 here. We know that this x minus 5 is a polynomial. Okay, that x minus 5 is a polynomial. Therefore, this is continuous. Okay, so that means for all the values x greater than or equal to 5, the function is continuous. And for all the values of x less than 5, there also we have one polynomial. Therefore, this is also continuous. Now, the question is, what about at x is equal to 5? Whether this function is continuous at x is equal to 5. Now, just listen, children. If you have breaking, okay, if you have breaking, here our function is splitted into 2. Okay, and that breaking point, that is 5. Okay, here our function splitted at x is equal to 5. Okay, so you need to check the continuity at your splitting point. okay, or your breaking point. You need to check the continuity at your breaking point. Here the breaking point is 5, okay, because our function is splitted into 2 at x is equal to 5, x greater than 5 and x less than 5. We have two different values for our f of x, and that two values, they are polynomials. Therefore, for all the values x greater than or equal to 5, we have a polynomial, and that is continuous. For all the values x less than 5, there also we have a polynomial, and that is continuous. Now our question is, what about at x is equal to 5? Is it continuous? We are going to check the continuity at x is equal to 5, and just look at the definition of your f of x. You can see that to the left of 5 and to the right of 5, you have different values for your f of x. Okay, this is your 5, and for all the values which less than 5, we have minus of x minus 5, and for all the values which greater than 5, we have x minus 5. Okay, that means to the left of 5 we have minus of x minus 5, and to the right of 5 we have x minus 5. Okay, that's why we are calling it as a splitting point or breaking point. Okay, now if you want to check the continuity here, we need to find out the left hand limit and right hand limit. We need to find the left hand limit and right hand limit. So first I am going to find left hand limit. Left hand limit is limit. We need to find out the left hand limit at x is equal to 5. So x tends to 5 minus, since it is left hand limit, f of x is equal to limit x tends to 5 minus, what is the value of f of x to the left of 5? Okay, that is minus of x minus 5, right? Minus of x minus 5, that is the value of f of x to the left of 5. Okay, that is equal to minus, just put x is equal to 5, 5 minus 5, and that we will get it as 0. So the left hand limit is 0. Now right hand limit is equal to limit x tends to 5 plus for right hand limit. F of x is equal to limit x tends to 5 plus, what is the value of f of x to the right of 5? To the right of 5, the value of f of x is x minus 5. Okay, and this is equal to, just put x is equal to 5, then 5 minus 5 is equal to 0. Here the left hand limit and right hand limit are equal, and we know that if the left hand limit is equal to right hand limit, then the limit value is that left hand limit and right hand limit. Okay, here the left hand limit is equal to right hand limit. Therefore, limit x tends to 5, f of x is equal to 0. That is equal to left hand limit and right hand limit. Now, what is f of 5? Now we need to find f of 5. F of 5. Look at the definition of your f of x. X greater than or equal to 5. X greater than or equal to 5. The value of f of x is x minus 5. Okay. So equal to 5 also the value of f of x is x minus 5. So this is, we have x minus 5 actually, that is 5 minus 5 is equal to 0. 5 minus 5 is equal to 0. Therefore, what we got actually, limit x tends to 5 f of x is equal to f of 5. Limit x tends to 5, f of x is equal to f of 5. Therefore, the function is continuous at x is equal to 5. Therefore, the function is continuous at x is equal to 5. Okay, now just listen. At x is equal to 5, our function is continuous. And to the left of this 5, we have a polynomial, therefore that is continuous. To the right of this 5, we have a polynomial, therefore that is also continuous. So, in total, the function is continuous for all real numbers. Okay. Now, the fifth question. F of x is equal to x if x less than or equal to 1. 5 if x greater than 1. Okay. This is our function, and we need to check the continuity at x is equal to 0, x is equal to 1, x is equal to 2. X is equal to 0, x is equal to 1, x is equal to 2. Okay. Now, just look at the definition of this function. We can see that this function is split into 2. That means there is one breaking point. What is that breaking point here? That breaking point here it is 1. The breaking point here it is 1. Okay. Now, the first case. Just draw the real line. 0, 1, 2. 0, 1, 2. Here x less than or equal to 1. X less than or equal to 1. To this side we have the function value that is x. And x greater than 1 we have the function value that is 5. Okay. So to the left of 1 we have the function value that is x. To the right of 1 we have the function value that is 5. Now x is equal to 0. Okay, consider x is equal to 0. We are going to check the continuity at x is equal to 0. And x is equal to 0. To the left of this x 0 and to the right of the 0 and to the left of the 0 we have only one function that is x. Okay. Just take the neighborhood, close neighborhood. Then to the left and to the right of 0 we have only one function value that is x. So limit x tends to 0, f of x is equal to limit x tends to 0, x is equal to, just put x is equal to 0, we will get 0. And f of 0 is equal to, here the function is f of x is equal to x. Here the function is x. So f of 0 is equal to 0. So what we got? Limit x tends to 0, f of x is equal to f of 0. Therefore, the function is continuous at x is equal to 0. Now, x is equal to 2 we will do. X is equal to 2. Now consider this 2. Just take a closed neighborhood. Then to the left of this 2 and to the right of this 2, the function value f of x is 5. A constant function we have. Then limit x tends to 2, f of x is equal to limit x tends to 2, 5 is equal to, there is no term which contains x, so we can't put x is equal to 2 and all. The constant function limiting value is that function itself, so this is equal to 5. And f of 2 is equal to, f of x is 5. If we have any term which contains x in our f of x, we can substitute x is equal to 2. Here the function is constant. For any value, the function takes 5 only. So for any value of x, the function takes 5 only. So f of 2 is equal to 5. That means limit x tends to 2, f of x is equal to f of 2. Therefore, the function is continuous at x is equal to 2. Now we will check the continuity at x is equal to 1. That 1 is our breaking point. To the left of this one and to the right of this one, we have different values for our functions. So, since we have different values, to the left and to the right we have different value for our function, we need to find left hand limit and right hand limit. We can't find limit directly. We need to find left hand limit and right hand limit. 1 minus f of x is equal to limit x tends to 1 minus left hand limit. To the left of 1, what is your function? To the left of 1, the function is x. So x is equal to, just put x is equal to 1, we will get 1. Now right hand limit is equal to limit x tends to 1 plus f of x. And what is your function value to the right of 1? What is your function value to the right of 1? That is limit x tends to 1 plus, to the right of 1 we have the function value that is 5. Since it is constant, the limit is also constant. What is your conclusion? Is it continuous at x is equal to 1? This is not continuous at x is equal to 1 because left hand limit not is equal to right hand limit. Left hand limit not equal to right hand limit. left hand limit not equal to right hand limit implies limit does not exist. Okay, if limit does not exist, that means our function is discontinuous at x is equal to 1. Okay, therefore our function is discontinuous at x is equal to 1.